If you've shipped a LangChain agent to production, you've probably felt that gut punch when the monthly API bill arrives. Or maybe your users are complaining that responses take 8, 9, 10 seconds to come back. The truth is, most agents are wildly inefficient by default, burning tokens and time on work that adds zero value. Today we're going to fix that. I'll walk you through the concrete techniques that have cut token costs by 60 to 80% in real systems and shaved seconds off latency, without sacrificing the quality your users expect. Let's start with the biggest hidden cost, your prompts. Every time an agent reasons, it resends the entire system prompt, the tool descriptions, and the full conversation history. If your system prompt is 2,000 tokens and your agent loops 5 times to answer one question, you've just paid for 10,000 tokens before the user even sees a response. The fix is ruthless prompt auditing. Strip your tool descriptions down to the essentials. A tool description that says, "Use this to search the company knowledge base for relevant documents," works just as well as a 3-sentence paragraph. Move static instructions out of every turn and into a single, tight system message. Next, attack the reasoning loop itself. The default React pattern is powerful but expensive because the model thinks out loud on every step. For many production tasks, you don't need open-ended reasoning at all. If your agent always calls the same 3 tools in roughly the same order, replace it with a structured chain or an explicit state machine. You'd be shocked how many agents are really just deterministic workflows wearing a costume. When you do need genuine reasoning, cap the maximum iterations. Setting max_iterations to 4 instead of the default 15 prevents runaway loops that quietly drain your budget on edge cases. Now let's talk about model routing, which is where the real savings live. You do not need GPT for class models for every step. Use a cheaper, faster model for classification, routing, and simple extraction, and reserve your expensive model for the final synthesis where quality actually matters. A common pattern: a small model decides which tool to call and formats the arguments. Then a larger model writes the final user-facing answer. This alone can cut costs in half while actually reducing latency, because smaller models respond faster. Caching is your next lever, and it operates on 2 levels. First, there's prompt caching, which providers like Anthropic and OpenAI now support natively. By marking your stable system prompt and tool definitions as cacheable, you pay full price once and a fraction of that on every subsequent call within the cache window. Second, there's semantic caching for entire responses. If 3 users ask, "What's your refund policy?" in slightly different words, you shouldn't hit the model 3 times. A vector-based semantic cache recognizes the similarity and returns the stored answer instantly, turning a 2-second call into a 20-millisecond lookup. Latency deserves its own attention because perceived speed often matters more than total speed. Stream your tokens. Even if the full answer takes 4 seconds, a user who sees words appearing immediately feels like the system is fast. Beyond streaming, parallelize independent tool calls. If your agent needs to query a database and call a weather API, and neither depends on the other, run them concurrently with Essentio instead of sequentially. That single change can cut a tool-heavy step's latency in half. Finally, you can't optimize what you can't see. Instrument everything with a tool like LangSmith or a simple custom tracer. Log token counts per step, latency per tool call, and the full prompt at each stage. When you can see that one particular tool is sending 6,000 tokens of context on every call, the fix becomes obvious. Put these together: lean prompts, smart routing, aggressive caching, parallel execution, and real observability. Apply even 3 of them, and your next bill and your users will thank you. Thanks for watching, and I'll see you in the next one.